Imagine a computer so powerful it could process data faster than all the world's supercomputers combined. A machine that could crack the most complex codes, optimize global supply chains in real time, and even help us understand the mysteries of our universe. This isn't the stuff of science fiction, but the promise of quantum computing. But is it the next tech revolution or just a billion-dollar illusion? In this video, we're diving deep into the quantum realm to explore this fascinating technology, its potential, and the challenges it faces. So, buckle up and get ready for a journey into the future of computing. Quantum computing, a concept that emerged from the scientific community in the early 1980s, is a rapidly evolving field that has captured the attention of scientists, technologists, and investors worldwide. It represents a significant departure from classical computing, leveraging the principles of quantum mechanics to process information in ways that traditional computers cannot. The essence of quantum computing lies in its ability to operate in a realm beyond binary 0 seconds and 1 second. It introduces quantum bits, or qubits, which can exist in multiple states at once, a phenomenon known as superposition. This characteristic, along with entanglement, where qubits become interconnected and the state of one can instantly affect the state of another, regardless of distance, allows quantum computers to process vast amounts of data simultaneously. The importance of quantum computing in the current technological landscape cannot be overstated. As we continue to generate and rely on increasingly large datasets, the limitations of classical computing become more apparent. Quantum computing promises to overcome these limitations, potentially transforming sectors such as cryptography, logistics, drug discovery, and artificial intelligence. However, the path to realizing the full potential of quantum computing is fraught with challenges. The technology is still in its infancy, with many technical hurdles to overcome. Furthermore, the high costs associated with developing quantum computers have led some to question whether it is a viable technological revolution or merely a billion-dollar illusion. This video aims to delve into the complexities of quantum computing, exploring its potential, the challenges it faces, and its implications for the future. It will provide a balanced perspective, drawing on the latest research and expert opinions to assess whether quantum computing is indeed the next tech revolution or a costly diversion. To fully grasp the concept of quantum computing, it's essential to understand the principles that differentiate it from classical computing. Classical computers, which include everything from calculators to supercomputers, operate based on binary bits. These bits, the smallest unit of data in a computer, are binary, meaning they exist in one of two states, 0 or 1. Every operation that a classical computer performs, from simple arithmetic to rendering complex graphics, is broken down into a series of binary operations. Quantum computing, on the other hand, introduces a new kind of bit, the quantum bit, or qubit. Unlike binary bits, qubits can exist in a state of 0, 1, or both at the same time, thanks to a quantum principle known as superposition. This means that a quantum computer with multiple qubits can represent and process a vast number of possibilities simultaneously. Another quantum principle at play in quantum computing is entanglement. When qubits become entangled, the state of one qubit becomes linked to the state of another, no matter how far apart they are. This means that a change in one qubit state will instantly change the state of its entangled partner, allowing for incredibly fast information processing. These principles of superposition and entanglement give quantum computers their extraordinary computational power. They have the potential to solve complex problems and perform calculations significantly faster than even the most powerful classical computers. For instance, tasks like factoring large numbers, which would take a classical computer billions of years to solve, could theoretically be done by a quantum computer in just a few seconds. However, harnessing the power of quantum mechanics for computing is no easy task. Quantum states are delicate and can be easily disrupted by environmental factors, a problem known as decoherence. Maintaining stable qubits for a sufficient amount of time to perform computations is one of the biggest challenges in the field of quantum computing. Despite these challenges, the potential of quantum computing is immense. It promises to revolutionize fields that rely heavily on computational power. From improving encryption algorithms to accelerating drug discovery and optimizing complex systems, the applications of quantum computing could be transformative. However, as with any emerging technology, it's essential to balance optimism with a healthy dose of skepticism. The journey to fully functional quantum computers is still underway, and only time will tell if the promise of quantum computing will be realized or if it will remain a billion-dollar illusion. The potential applications of quantum computing are vast and varied, spanning numerous industries and fields of study. One of the most promising areas is cryptography. Today's encryption systems, which secure everything from online transactions to confidential communications, rely on complex mathematical problems that classical computers find difficult to solve. quantum computers, with their superior computational power, could crack these codes with relative ease. On the flip side, this also means that quantum computers could be used to create virtually unbreakable encryption systems, ushering in a new era of cybersecurity. Another area where quantum computing could make a significant impact is in solving optimization problems. These problems, which involve finding the best solution from a set of possible options, are common in logistics and supply chain management. For instance, a delivery company trying to find the most efficient routes for its drivers is an example of an optimization problem. While classical computers struggle with these problems as the number of options increases, quantum computers could potentially solve them more efficiently. In the field of drug discovery, quantum computing could also play a transformative role. The process of discovering new drugs involves simulating different molecular structures and their interactions, a task that requires immense computational power. Quantum computers could significantly speed up this process, potentially leading to faster discovery of new drugs and treatments. Despite these promising applications, it's important to note that we are still in the early stages of quantum computing. Many of the potential applications are based on theoretical models and have yet to be realized in practice. Moreover, developing a fully functional quantum computer is a costly endeavor. Major tech companies like IBM, Google, and Microsoft, as well as numerous startups, are investing billions of dollars into quantum computing research and development. These companies are betting on the promise of quantum computing, but it's not without risks. The technical challenges are significant, and there's no guarantee of when or even if they will be fully overcome. This has led to some skepticism and criticism. Some argue that the hype around quantum computing is outpacing its actual progress, leading to inflated expectations and potentially wasted investments. However, it's also important to consider the potential cost of not investing in quantum computing. If the technology does live up to its promise, companies and countries that have not invested in quantum research could find themselves at a significant disadvantage. In this sense, the quantum race is not just about technological advancement, but also about economic and strategic positioning in the future digital landscape. The journey towards fully functional quantum computers is not without its hurdles. The technical challenges that scientists and engineers face in this field are significant and multifaceted. One of the most prominent challenges is maintaining quantum coherence, the delicate state in which qubits exist. Quantum states are incredibly sensitive to their environment, and even the smallest disturbance can cause a qubit to lose its quantum state, a phenomenon known as decoherence. This makes it incredibly difficult to maintain a stable quantum state long enough to perform meaningful computations. Another significant challenge is quantum error correction. Unlike classical computers, where a bit is either in a state of 0 or 1, qubits can exist in a superposition of states. This makes them susceptible to errors that are much more complex than those in classical computing. Developing effective quantum error correction algorithms is a critical area of research in quantum computing. In addition to these technical challenges, there are also practical considerations. Building a quantum computer requires specialized materials and conditions. Qubits need to be isolated from their environment to maintain their quantum state, which often requires cooling the system to temperatures close to absolute zero. This makes quantum computers expensive and challenging to build and maintain. Despite these challenges, there is a significant amount of optimism in the field of quantum computing. However, this optimism is not without its critics. Some argue that the challenges are too great and that the promise of quantum computing is more of a mirage than a reality. They point to the slow progress and high costs associated with quantum research and development, arguing that the resources could be better spent elsewhere. These criticisms are not unfounded. The path to quantum computing is uncertain and the timeline for when we might see fully functional quantum computers is unclear. However, it's also important to consider the potential payoff. If the challenges can be overcome, the impact of quantum computing could be revolutionary. As with any emerging technology, there is a degree of risk involved. The question is whether the potential rewards justify the risks. This is the crux of the debate surrounding quantum computing. Is it the next tech revolution or a billion-dollar illusion? The race to achieve quantum supremacy, a term coined to describe the point at which a quantum computer can perform a task that classical computers practically cannot, has become a global competition. This race is not just about technological advancement, but also about economic and strategic dominance in what could be a pivotal technology of the future. Major tech companies like Google, IBM, and Microsoft are at the forefront of this race. Google, for instance, announced in 2019 that it had achieved quantum supremacy with its 53-qubit quantum computer, Sycamore. IBM, a pioneer in the field, has been developing quantum computers and offering quantum computing services through its IBM Q network. Microsoft, on the other hand, is taking a different approach with its pursuit of topological quantum computing, a form of quantum computing that could potentially provide more stable qubits. In addition to these tech giants, numerous startups are also making significant strides in quantum computing. Companies like Rigetti Computing, D-Wave Systems, and IonQ are developing their own quantum computers and contributing to the advancement of the field. The quantum race is also a matter of national interest. Countries like the United States, China, Canada, and several European nations are investing heavily in quantum research and development. They recognize that dominance in quantum technology could have significant economic and strategic implications. However, it's important to note that while the quantum race is heating up, we are still in the early stages of this technology. Many of the claims of quantum supremacy need to be taken with a grain of salt, as they often involve specific tasks under ideal conditions. The development of a general-purpose quantum computer that can outperform classical computers on a wide range of tasks is still a work in progress. Despite the challenges and uncertainties, the potential of quantum computing continues to drive investment and research. Whether it will lead to a technological revolution or turn out to be a billion-dollar illusion remains to be seen. What is clear, however, is that the journey towards quantum computing is shaping up to be one of the most exciting narratives in the tech world. The implications of quantum computing extend far beyond the realm of technology. If realized, it could have profound impacts on businesses, economies, and society at large. From a business perspective, quantum computing could revolutionize industries that rely heavily on data analysis and complex computations. Financial institutions could use quantum algorithms to optimize trading strategies or manage risk more effectively. Pharmaceutical companies could accelerate drug discovery, potentially saving billions of dollars and years of research. Logistics companies could optimize routes and supply chains in real time, significantly improving efficiency. On a broader economic level, quantum computing could drive significant growth and productivity gains. Countries and companies that lead in quantum technology could gain a competitive edge, attracting investment and talent. However, this also raises concerns about a potential quantum divide, where countries that lag in quantum research could find themselves at a disadvantage. From a societal perspective, quantum computing could have far-reaching implications. It could enable more accurate climate modeling, helping us understand and address climate change more effectively. It could also raise new ethical and security concerns. For instance, quantum computers could potentially break current encryption systems, posing risks to data privacy and security. However, these future implications are contingent on overcoming the significant technical and practical challenges that quantum computing currently faces. The high costs and slow progress have led some to question whether quantum computing is a viable path forward or a costly distraction. Despite these uncertainties, the pursuit of quantum computing continues unabated. The potential benefits are too significant to ignore, and the risks of falling behind in the quantum race are too great. Whether quantum computing will live up to its promise or turn out to be a billion-dollar illusion is a question that only time will answer. What is certain, however, is that the journey towards quantum computing will continue to be a fascinating journey of discovery and innovation. As we reach the conclusion of this exploration into the world of quantum computing, it's clear that we stand on the precipice of a potentially transformative technological revolution. Quantum computing, with its promise of unprecedented computational power, could reshape industries, economies, and societies. However, it's also evident that the path to realizing this potential is fraught with significant technical and practical challenges. The principles of quantum computing, while theoretically sound, are incredibly challenging to implement in practice. Maintaining quantum coherence, correcting quantum errors, and building practical quantum computers are hurdles that scientists and engineers are still grappling with. These challenges, coupled with the high costs of quantum research and development, have led some to question whether quantum computing is a viable technological revolution or a billion-dollar illusion. Despite these criticisms, the pursuit of quantum computing continues unabated. Major tech companies, startups, and nations are investing heavily in quantum research, driven by the potential benefits and the strategic importance of quantum technology. The quantum race is not just about technological advancement, but also about economic and strategic dominance in a potentially pivotal technology of the future. The future implications of quantum computing are vast and varied, from revolutionizing industries like finance and pharmaceuticals to raising new ethical and security concerns. The impact of quantum computing could be profound. However, these implications are contingent on overcoming the significant challenges that quantum computing currently faces. In conclusion, whether quantum computing will be the next tech revolution or a billion-dollar illusion is a question that remains unanswered. The potential is immense, but so are the challenges. What is certain, however, is that the journey towards quantum computing will continue to be a fascinating narrative of discovery, innovation, and the relentless pursuit of knowledge. As we continue to explore the quantum realm, we can only wait and see what the future holds. As we venture further into the quantum realm, the mysteries and potential of quantum computing continue to unfold. Will it be the next tech revolution or a billion-dollar illusion? Only time will tell. But one thing is certain, the journey is going to be fascinating, and you won't want to miss a moment of it. If you've enjoyed this deep dive into the world of quantum computing and want to stay updated on the latest developments, consider subscribing to our channel. We'll continue to bring you in-depth analysis and insights into the most exciting and transformative technologies of our time. And remember, your subscription helps us continue our work, exploring the frontiers of technology and bringing you the knowledge you need to navigate the future. So hit that subscribe button and join us as we journey into the exciting world of quantum computing and beyond. Thank you for watching, and we look forward to seeing you in our next video.